Hi OSLO users. In this video I'm going to talk about the RIM reference ray mode out of the ray aiming modes. So the RIM reference ray aiming mode traces reference rays at the center, top, bottom, and the FX plus 1.0 right, which is the right extreme reference surface location. This is what it does by default. If you do have a system that does not have rotational invariance, in other words, it does not have rotational symmetry, it also will trace the FX minus 1.0 or left extreme reference surface location. When it has that type of symmetry, if you know the plus 1.0, you know the minus 1.0 automatically. So it will trace essentially the edges of give you an idea of the extremes of the pupil, instead of just tracing a reference ray in the center like this central reference ray aiming mode. Of course, this is a little bit more expensive because we're tracing more reference rays. You can use it with non-circular reference surface apertures, although I always suggest you take care in such cases to make sure that the pupil or the system stop is being sufficiently sampled, correctly sampled, and getting out to the edges. So just be a little bit careful when you're using it in those types of cases. Now, for best ray tracing efficiency, you should also limit the checked apertures to ones that are actually going to be blocking rays. This is because OSLO will actually check will verify that the rays going through every single one of your checked apertures. So that can slow it down a little bit, and so there's no reason to check an aperture unless you know that's going to be one that's going to be blocking light and vignetting the system. You should take care in a couple of other cases as well. Take care if a system is not well corrected, because in those types of cases, you might get a reference ray getting blocked and you'll get an error message. There are some ways that you can work around that using other ray aiming modes, as well as turning checking off or making your surface a little bit bigger. There's some ways around that, but that is one of the negatives of using this type of method, is that you'll get an error message if that ray is getting blocked. The other thing is, if a system is not well corrected, you may get some in terms of pupil aberration, you may get some bad sampling of the pupil. OSLO, when it does this mode, it assumes a linear spacing between the rays, and if you have a lot of pupil aberration, then that will not be a very good approximation. So if it's got a lot of pupil aberration or is not well corrected, take special care. Look at our documentation to look for some more details. I'll show that in just a moment as well. Do not use vignetting factors with this mode, and this is because this is in a sense replacing the use of vignetting factors with the central reference ray mode. So here, just to show you, if I have a circular reference surface, then the rays that it would be tracing for a symmetric system would be the top, the bottom, the middle, and of course the right. The middle is the central reference ray mode, normally traces a reference ray for that location. So this one adds these outer rays. And then if you have a system that does not have symmetry, as mentioned earlier, does not have rotational symmetry, it will also need to trace this one in red. But if you know the one on the right, you will know the one on the left if that system has rotational symmetry. So let's just take a quick look at the documentation and the double Gauss example afterwards. So this is the optics reference, and it's very similar to what I've just said, a little bit of extra detail. This is one of the cases that actually the online documentation has a little bit more information. So if you go to our help in the program, you get this quite a bit of text here on the RIM reference mode. Go to the ray aiming modes and go down to the RIM reference ray mode. Most of what is said in here I have given you some treatment of, but I do suggest you read this before you use this RIM reference ray mode, just to be sure that you understand all the little factors involved. I've mentioned quite a bit of it, as I said, in here. So let's now look at the example, the double Gauss lens. So what I've done here, if we go to the lens drawing conditions, is I've made sure that the lens aperture stop is being drawn. I've changed to 11 rays for the on-axis and then the full field, and made sure that we're tracing the pupil from minus 1.0 to 1.0. And for the double Gauss lens, I've also opened up I've changed to 1.0 field point and traced the beam and how it looks going through. As you can see here, surface 6 is the stop. If we open this up, you can see that surface 6 is indeed the stop in this system. Also note that the checked surfaces are just 1 and 11 in this case. So that's the way that this lens has been set up, and I've got the beam footprint, and I've got this the picture of the lens here as normal. So now if we go to the general operating conditions, you'll see we're in the central reference ray mode, and you can see here for this full field of view, you can see that we're not quite filling the pupil at the top correctly. And you can see this also going pretty clearly when you look at the blue rays here. They are not going all the way to the top. So this is a case where the central reference ray mode, there's no vignetting factor set on this, and so what you're seeing here is just where it thinks it would be, but there's some pupil aberration in this case, and that's causing this the size of the pupil to not be completely correctly approximated by the central reference ray mode. So the clear thing to do in this case to fit the video is we're going to switch to the rim reference rays. In this case, we go ahead and do this, and we update this. And now if we look at this picture, you can see pretty clearly, while we are now coming out to the edge, or very, very close to the edge of this aperture. So that's really good. And then if we go here, you can see that we are getting out to the edge. There's a little bit, sometimes there's a little bit of rounding and some other factors like this. So you can see a couple of them getting blocked here, but that's really no big deal. The key is you can see now by tracing the reference rays all the way out to the edge, here at the top, the right, and the bottom, and we get the left for free because this is rotation symmetric. We're now filling the pupil correctly. So that's the basic purpose of this rim reference mode, and I've shown you enough of the pitfalls. So if you are going to use it, definitely read the documentation first.